Hello everyone. Thank you for supporting my educational video. Today's video, I'm going to share with you how to go about solving problems involving before-after concept or items changed using model drawing. The outline again, there are 4 concepts to the before and after. I have shared with you in my earlier videos, difference unchanged, one item unchanged, total unchanged. Today, I'm going to focus on all items changed. Now, all items changed, also known as external changed, involves something very abstract. In all items changed, the 2 items in the ratio or in the question, the changes that take place before and after, from before to after, the value that changed, they are not equal to each other. Alright, so usually in this abstract situation, we have 2 unknown variables. The before variable is unknown for both items. Right? So some schools, they use units and parts and then adding up using simultaneous equations way of solving. I'm going to present my sharing with you using a table. I call it the Bca table, the before changed after table. Now, to illustrate how to go about solving before after concept or items changed question, I'm using this PSLE question 2018 paper 2 question 14. It is a 4-mark question. Alright, I'm going to begin. N had a total of 285 red and blue bits. So we know the total bits, but the very first line, we can't do much. Okay, I'm going to read on. She used 45 red bits. She used 40% of the blue bits. Okay, so if you have noticed, in this particular question, we have multiple topics: whole numbers, fraction, ratio. Okay, so it complicates a lot of, it complicates matter really. All right, so nowadays PSLE questions are a combination of topics. Okay, don't worry, I'll try my best to help you. Now, I'm going to start off doing the part A because it is only 1 mark. It is extremely easy. Okay, part A. What fraction of the blue bits did N use? Which is actually here. Okay, so N used 40% of the blue bits. So 40% can be converted to a fraction, which is 40 out of 100, very easily. Okay, so this is just a conversion of between 2 topics, percentage and fraction. So 40% is the same as 40 out of 100, and it should be simplified to 2/5. Okay, part A is solved. Okay, so using part A, I can draw my Bca table. Alright, so it goes like this. Okay, it's 4 columns and 4 rows. Let's talk about the column first. The column represents the 2 items, the 2 variables. So I have the color red and the color blue. And the last column will be their total. Okay, now the row that is proceeds would be the before. See, so this whole row represents before, and then this is the change row, and then the final row will be the after. So it's called BCA, BCA table, right? Before change, after table. Okay, now let's plug in the information given in the word problem, and had a total of 285. So here should be 285. Okay, easily understood. So total bits before 285, blue plus red 285. Now she used 45 red ones, so I'm going to subtract. Use means there's a change. I'm going to subtract 45 from here. So this is the information that I can plug in, minus 45. And she used 40% of the blue bits. Now 40%, if you can look at the fraction, is 2 out of 5. What does it mean? That means 2 units used, right? 2 units used, and there should be 5 units of blue at first. Okay, right. Let me explain the BCA table. Looking at the table, we know that the blue bits at first, there should be 5 units of blue bits before, and used 2 units of blue bits, and she ended up with 3 units of blue bits. Okay, all right. Now I think the blue column should be quite easily understood. It's actually using the part whole concept. Okay, I'm going to read line 2. Like line 2 says that the ratio after that was 1 to 3. That means 1 for the color red and 3 for the color blue. So if you look at our after row, right, the 3 units belonging to blue happens to be the same 3 units here. Wow, so this is good. Okay, so the red ones, I can plug in 1 unit without having to worry about anything. Okay, so from here I can conclude that in the end, there should be 4 units of bits in total. Alright, now, so for the red bits before, if you use the working backwards concept, you should know that it is 1 unit plus 45. Right, it's a part whole concept, working backwards, 1 unit plus 45, 1 unit plus 45, so it's a reverse operation. Okay, now looking at the before, row, I can actually construct an equation involving units. All right, so let me go through a bit slowly. 1 unit plus 45. Okay, wait, let me rewrite. It's untidy. So 1 unit plus 45 belongs to red at first, plus 5 units belonging to blue at first, and the total is 285 at first. So looking at the very simple equation, I can conclude that 6 units must be 285 minus 45, meaning 6 units should be 240 bits. So 1 unit would be 240 divided by 6, that gives me 40. Okay, now actually I can even solve part B from here. So to solve part B, okay, let's take a look. Part B asks, how many bits did n have in the end? How many bits did n have in the end? So in the end, which is here, n had 4 units of bits. So 40 times 4, that gives us 160. And the question is solved. I'm going to share the same question using model drawing. So I will do this a little bit faster because it's easy. All right. So let's draw the model, but I will start drawing the model using the after ratio 1 to 3 because that is the only info that I can draw very accurately. 1 unit belonging to the red bits and 3 units belonging to the blue bits. So it goes like this. Pardon my drawing again. Yep, like this. Okay. Now let's plug in all the information that we have by doing something called working backwards. So the red ones, she used 45. So I'm going to put back the red ones. I'm not sure how big it is 45, but doesn't matter. So this is used. This part is left. Okay, I'm going to shade the left. All right. So this must be the left for the blue bits. Okay, if you can remember what we did in our previous slides for part A. All right, the fraction used is 2/5. The fraction used is 2/5. Okay, that's why it is left with 3/5 now. Okay, I'm going to plug back the 2 units into the model. So it goes like this. So this is used. This is the blue bits used. All right, now let's update our model a little bit. Okay, so this is 1 unit, 1 unit. Okay, let me change the, okay, I think it should be okay. 1 unit, 1 unit, 1 unit. So there are 5 units of blue bits at first. And then for the red ones, it is 1 unit plus 45 at first. And the total should be 285. Okay, so now we are back to the same equation that we saw earlier in my previous slide. So 6 units will be 285, subtract 45, that gives me 240. So 1 unit will be 240 divided by 6, that gives me 40. Okay, very easily done. Now, part B is solved very soon. To do part B, how many bits did n have in the end? So in the end means this part. Alright, in the end, she was left with 4 units. So 4 units will be 40 times 4, that gives us 160. The question is solved using model drawing and cross idea from the earlier one, the Bca table. Here's a quick recap. Before after concept all items changed, we need to have, there should be 2 variables usually, and the 2 variables are unknown, right? They are unknown variables, so usually we use units and parts to represent, but for me, I use units only because the whole question can be simplified to just using units alone. But don't worry, in my future videos, I will share a different all items change question, and then there will be units and parts in it. Okay, now remember, for all items changed, both items, the value that changed should not be the same at all. That means the item A value changed should not be equal to the item B value changed. So the change can be positive, that means it's being added to the item, or it can be negative, that's being removed before and after. Okay, so all items changed is a rather abstract. All right, so if you have lack of information, normally we will use unknown variables, units and parts. So algebra is actually indirectly used in this type of question and have to be solved using simultaneous equation. Okay, all right. Now, I've actually shared with you the before after concepts, all 4 concepts, using my 4 videos. Okay, so previously I shared the difference unchanged, one item unchanged, total unchanged, and today in this video I shared with you the all items changed. So the changed family of 4 concepts. All the videos are uploaded. Okay, the coming videos I'm going to share with you equal fractions, commonly known as equal numerators. And I'm also will be sharing with you making assumption, also known as making supposition. All right, if you like my today's sharing, my video, it's clear and easily understood, uh, click on the like button. Feel free to share with anybody who is interested, wanting to find out more about how to go about solving before after concept using model drawing. And to receive my future videos, right? Do subscribe and click on the bell button. Okay, once again, thank you for your kind attention, your kind watching and listening. Do take care. Bye bye for now.